Today, I'm going to be talking to you about the musculoskeletal system, which is really two systems, arguably, the skeletal system and the muscular system, but they work very closely together. And we'll be talking a little bit about the physiology and the anatomy of the musculoskeletal system and some of the herbs that we might use to help with supporting those systems in people that we might be working with. So the skeletal system consists mainly of the bones and the joints, as well as the blood vessels and the marrow that are part of them. And then the muscular system is the skeletal muscles. These are also sometimes called striated muscle, as opposed to smooth muscle or cardiac muscle. Smooth muscle is the kind of muscle that lines the digestive system. Cardiac muscle, of course, is the muscle of the heart. And on a cellular level and texturally, these are different from the muscles that make up most of the body, the muscles of the body. So the muscle fibers in the muscles of the skeletal muscles are arranged differently. And crucially, the skeletal muscles, for the most part, are voluntarily controlled. Now, there are things like spasms and reflexes that do happen involuntarily with them, but for the most part, they're voluntarily controlled, whereas the muscles that push food along through your digestive system or that make your heart beat, you don't really have to think about their operation in order for them to operate. They just kind of do their thing, even if you're unconscious, even if you're not focusing on them at all. They go about their business, whereas skeletal muscles generally require an intention in order for you to make them contract and relax. So they're also called voluntary muscles, as opposed to involuntary muscles. Notably, the diaphragm is kind of voluntary or involuntary. It is something that does work on its own. It's a smooth muscle, so it's not really like the skeletal muscles. It's a smooth muscle, but you can stop breathing, hold your breath, things like that if you choose to, in which case it's partly that you're countering what it's doing using other muscles, but also you can guide and change what this muscle is doing, even though it will work without conscious thought if you are not directing conscious thought towards it. So the skeletal muscles generally are attached to the skeleton instead of being part of the organs or attached to the organs, and they're sort of arranged in pairs. So for the most part, there will be one of them that moves a bone one direction when it's contracted, and one of them that moves the bone the opposite direction when it's contracted. A really easy example to think of is in the arm, you've got the bicep muscle here, tricep muscle under here. Tricep muscle is flexed or tensed when the arm is extended. Bicep muscle is tensed when the arm is flexed. So one pulls and one pushes, essentially, or causes your arms to be able to pull and push. They're both pulling on the muscle from on the bones from different directions. So I'm going to talk first about, and today I'm not really going to go into great detail about the names of particular bones and muscles. This is a good thing to learn, but it's something that's probably good to study on your own rather than in a lecture type of situation, because you can get a diagram and look at it and it will illustrate where everything is. If you look up skeletal system or skeletal muscles on Wikipedia, you can find pictures, you can find descriptions of all of them. There are a couple hundred bones in the human body, and there are lots of muscles. I've never really counted them, but lots of different muscles attached to those bones. And I'm going to be talking mostly about the physiology of the muscles and bones, and then, of course, about how we support those structures and functions with herbal remedies. So I want to talk first about the bones. The bones are hard tissue. They're well, the bones and teeth are the hardest tissues in the human body. And different bones are of different thicknesses and strengths. So the delicate bones inside of your sinuses and inside your nose are not much thicker than a piece of paper and are easily damaged if they come in contact with anything, although they're surrounded by heavier, more robust bones. The weight-bearing bones in your body, like the femur, the pelvis, the bones of the spinal column, tend to be very robust, very strong for the most part. And that strength, a lot of that strength comes from mineralization, from minerals being deposited in the bones. And that is a whole process that happens in people's bodies and that sometimes needs to be supported. So when we start out as embryos and as tiny babies, we don't have a lot of mineralization of our skeleton. What we mostly have is protein. All of the bones consist of a protein matrix with minerals deposited in that protein matrix. And the minerals are within the cells. They're not extracellular. So a bone cell has the bone minerals in it, but it also has protein. And so overall, the bone is like a framework of protein. You could think of it as like a protein grid with the little boxes of the grid being filled up or not with minerals, especially calcium, but also magnesium, potassium, lots of other light metals in oxide form are mostly what they are. So calcium oxides being the most prominent thing. And we get these from our food. Our food gets it from minerals that are dissolved in the water that the plants are absorbing. The plants here in central Kentucky are growing over a bed of limestone, and that limestone in turn is the skeleton of sea creatures, microscopic sea creatures that lived eons ago, and they absorbed the minerals directly from the ocean, which of course is very full of minerals and salts and things, and turned into a reef, turned into a large deposit of calcium, and then that gets into the plants and then gets into the animals as well, milk and whatever. And so those minerals that are in your bones have existed since the beginning of the world. And so like calcium can never really become anything that isn't calcium. It can be different forms of calcium, like calcium chloride, which is a salt, or calcium oxide, but it's still going to be some form of calcium. And there's a fixed amount of it in the world, a large amount, but a fixed amount of it in the world. And there's no real way for living things to synthesize calcium. They can only consume it from the environment. And that's true of minerals in general. Most of them have as their basis some element from the Earth's crust that is geological, and it's absorbed into plants and then passed into animals, including ourselves, from the plants. So the bones are like a proteinaceous grid filled with deposits of minerals that make them hard and strong. In a baby, their skeleton is not very strong. People sometimes say that babies are just cartilage, skeletons are just cartilage, but that's not entirely true. But what is true is that their bones are not fully mineralized, and that they have growing parts of their bones that are just protein with very little mineral deposit in it. And so that remains true throughout childhood and basically up until we reach nearly our full adult height, which often happens, in early adolescence. So up until that time, there's part of the bone that is still not very mineralized, that is still mostly just protein that is able to grow and elongate. And it will typically have mineralized portions on either side of it growing towards one another. And once those have met, and there isn't any more bone that is just mainly protein without the mineralization, a little bit of growth can still happen, but it's just a little bit, and most of it is already, it's almost all of a person's growth in terms of height has already happened. After that point, bones can thicken, they can harden, they can change in various different ways, and of course, if they break, they can heal. We also call that remodeling, but they can grow back together when a part of them is broken. But they don't tend to elongate any further after that. So, for a lot of people, that process is basically finished somewhere around the age of 9 to 15 or 16, somewhere in that part of life, people have achieved their adult height, essentially. So bones do continue to change throughout our lives. So the bones reach their adult length and the person reaches their adult height, and then the bones become progressively more mineralized and stronger as the person ages into adulthood. And then they stay fairly consistent, although bones that are stressed, bones that have, at that point, it depends a lot on what the physical activity of the person is. So if a person is developing their muscles, it will develop the bones under those muscles as well. It will make the bones to get stronger and harder, and sometimes develop protuberances, places that stick out where the muscle is attached to. Sometimes those will grow bigger as the muscles grow bigger. And these are like anchor points for the muscles where they attach to the bone. So that changes throughout a person's life. And then as people start to get some age on them, their endocrine system isn't producing as much of the same hormones. There are a couple of different hormones that cause the body to deposit minerals in the bones. And there are also some different hormonal situations and hormones themselves that cause the body to release minerals from the bones. And so the bones are acting as sort of like a storage or like a bank account for minerals, where some is being put in all the time and some is being taken out and used. So your body needs calcium to run your nervous system, and that calcium is coming out of the bones, hopefully not at a faster rate than it's being put into the bones. But there are different messaging molecules, different hormones in the body that cause each of those things to happen. So for instance, estrogen and a thyroid hormone called calcitonin both work to make the body deposit calcium into the bones. In order for calcium to get deposited, there also has to be a good balance of magnesium, because for your nerves to work right, there can't be too much of an imbalance between those things. So if you don't have magnesium, your body will not deposit calcium. So it's considered a cofactor in bone strength and bone healing. So vitamin D is another molecule that helps to promote mineralization of bones. As people age and they get less of the substances in their body that promote mineralization, and often also as they get less physically active, their bones tend to lose density, and there is a possibility of having weaker bones. And so, in other words, more minerals are coming out than are being put in, and the bones, that matrix of the bone is getting more and more spaces in it that don't have calcium deposited in them. And so it makes the bones more brittle. And this is significant, especially because, well, for a couple reasons. One is that it affects physical strength. And the other is that, not the only other, other is that it makes someone more susceptible to a broken bone, which can be a major problem if you're in this stage of life, if you're in this type of health situation and you break a bone and your bones are already losing more calcium than they're gaining, then it can be very hard for your body to repair that bone. It's not impossible, but it doesn't always happen the way that it would in a younger and healthier person. There are also some drugs that can weaken the bones, especially steroids. And when I say steroids in this context, I don't mean anabolic steroids. I mean anti-inflammatory steroids like cortisone and prednisone that are used to suppress inflammation. They can have the side effect, especially if they're taken long term, of weakening the bones. Mm-hmm. So let's see. So at the same time, or on the flip side of that, there are things that cause the bones to get stronger. And one of the main things, besides the hormones that I already mentioned, is weight-bearing exercise. Just like muscles get stronger when they're used and stressed, bones get stronger when they are used and stressed. So if someone's bones are being used to carry weight, the body's going to assign a higher priority to that tissue than if they were not so much. And so more strength in the bones is going to be developed. The other thing that plays a huge role in bone healing and strength and development is protein. Because protein is like the foundation of these bones, lack of protein is going to gravely affect their ability to develop, as well as their ability to heal. Now, you may have at some point seen a science project, science experiment type of thing, where someone will take a bone and soak it in a weak acid like vinegar, which dissolves the minerals out of it. And then what you're left with is the protein matrix, which is just sort of a floppy, bone-shaped piece of softer tissue. And so that is, kind of what it is. That's like your skeleton. That's the structure that your bones are being built on, the protein scaffolding that they're being built on. And so if protein is not there, it can't form that, and there's no place for the minerals to go. One place you see this especially is in malnourished children, because you remember how I said there's like a certain amount of time in someone's life before the bones stop growing, stop elongating. So probably the reason that people now are a little bit taller on average than people in the past is because, generally speaking, we're less likely to have had a period in our childhood where we were malnourished. If you were living 500 years ago or 1,000 years ago or 2,000 years ago, there would very likely be a famine somewhere, or not necessarily a full-on famine, but a food shortage somewhere in your family's life during the time that you were growing up. So if you had a year where you weren't getting enough protein for you to grow, you would still stop growing at about the same age, and you would not have grown as much. So that's something that doesn't happen nearly as often or to nearly as many people now. Not to say that it doesn't happen at all. It definitely does happen to a lot of individual people and to quite a few places as well, where it's happening to whole populations, but not as routinely as it used to. And so fewer people are losing eventual adult height as a result of that sort of thing, which brings the overall average up, even though the range of people's heights has always been about the same. There have always been some people who were well over 6 feet, rare people who were 7 feet tall, rare, unusually short people, and lots of people who were somewhere in the middle. But it's been skewed a little bit higher, an inch or two higher over the couple hundred years during which we have good records. But much beyond that, it gets kind of hard to judge, really, because you'll have occasional descriptions of people, but not measurements where whole populations or large groups of people got measured. So protein is really important. Adequate protein in the diet is really important at all stages of life for bone health and for health in many other respects as well. And in order for there to be adequate protein, there also has to be an adequate number of calories. Otherwise, the protein will just get burned as calories and not made into good stuff like bone tissue. So that's kind of an overview of the process of how bones grow. There are a couple of different kinds of bones in the body based on shape. Sometimes they're categorized as long bones, short bones, and flat bones. And long bones are things like your femur or your humerus, like the arm bones, leg bones that are, long. And then there are short bones like the bones of the hand, which are almost like little pebbles. And they all fit together with a little bit of connective tissue in between them, cartilage in between them, and tendons to bind them together. And then there are the flat bones of the skull, especially, and also the sternum. They're just sort of like flat pieces of bone that join with other bones on their edges. So the long bones have more marrow inside them. They have hollow spaces in which there's fat, in which there's circulation of fluids and lymph, and in which there is also the production of certain types of immune cells. Lymphocytes, some of which are developed from start to finish inside the bones, and we call those B cells, some of which leave the bones and then migrate to the thymus gland and are finished developing there, and those are called T cells. So B cells and T cells are both at least partly developed inside the bones of the body and play a huge role in the body's innate immunity. And so that's something that people aren't always thinking about the bones, is that the bones are they play a lot of roles in the body. They're developing immune cells. They're a storage, a form of storage of electrolytes and minerals, and those electrolytes and minerals play a role in how the endocrine system functions, and how the kidneys function, and how the muscles function. And then the bones also have a sensory role. You can feel things in your bones, literally, particularly weight bearing and proprioception. So like how heavy something is and your position and balance, bones play a role in that too, because bones have nerves in them and they have fluids in them and things like that. So they're actually playing a sensory role as well, as in addition to being protective and structural and all that. With bones in general, there are some layers involved. There's the inner layer of the bone, which is the bone marrow, and that's kind of the tissue there. The tissue is less mineralized. There's more fat inside that part of the bone. There is more circulation and fluid inside that part of the bone. And then there's the hard part of the bone, what we usually think of as bone, which is like the part that's left behind after something has turned to a skeleton. The whitish hard tissue of the bone. And then around that, in a living person or living whatever else that has bones, there's a layer called the periosteum, which is like it has almost like a plastic wrap type of consistency to it, but it's a softer tissue membrane around the bone that helps to protect the bone itself from getting cracked, and helps to hold fluid in the bones and kind of regulate the flow of stuff in and out of the bones. So those are kind of different, like large visible layers of the bone. And then when you look at the cells of the bone, there are sort of like layers and layers of mineral and protein tissue. And there are passageways in and out of those layers that allow the exchange of fluids, of circulation and blood cells and things like that coming to the bone cells. And of course, allow minerals to get deposited and undeposited. So they're more complicated than people tend to think. If you look at a bone, you'll often see a small hole or a few small holes leading into the bone. Those are called a hole like that is called a foramen, and it's where a blood vessel and nerves will go into a bone, and from there they'll branch out inside the bone. But if you look at a bone sometime, you can usually see some place like that on it. And there are some, there's some on the jaw, on the sides, that are place where there's a lot of nerves and blood vessels. There's different ones on different bones throughout a person's body. But just like any other tissue, bone is living tissue, and it is capable of healing, capable of being harmed, and tends to have a lot of fluid in it. Tends to, the bones are juicy. You don't really think of that when you're thinking of bones that have been outside of a person or an animal, but inside a living person, bones are kind of awash in fluid, and so are very, heavy with both water and oil, lipids in the form of fats, and plasma and lymph is mostly water. So that's kind of a general overview of what the physiology of the bones is like. And then the skeletal muscles are attached to the bones. Usually when people describe the muscles, they'll talk about an origin and an insertion, which are just kind of like the two ends of the bone, the origin being the one that has that's larger, basically. It's kind of an arbitrary, in my opinion, a sort of unfortunate term, because it's not as though the muscle begins there in any real way. It's from point A to point B the whole time, but it has two endpoints, or sometimes it has multiple endpoints, but it has at least two places where it's anchored to the skeletal system. None of them are just kind of floating by themselves. That they're attached to the skeletal system at more than one point, so that when they contract, they can bring those 2 points closer together. So muscles contract in response to signals from the nerves, and that's mediated with electrolytes that help to conduct those nerve signals. And those electrolytes are things like sodium and potassium, and to some extent calcium and magnesium as well. And so those are all minerals. Those are all geological things that are coming from the soil into our food and into our bodies. And if somebody does not have the right balance of these substances, then the electricity in their muscles is not going to get conducted in the right way, and you're going to get cramping, which is when a muscle tenses up too much. It tenses up sometimes to the point where it can't voluntarily untense. A place that people experience this a lot, that's really obvious that that's what's going on, is when they get a cramp in the back of their leg. Charley horse, as people call it. And you can stretch that out by changing the direction your foot is going, but you might not be able to do it just intentionally. You might have to like press your foot against something and stretch it out. So that's an example of sort of a glitch, something going wrong with the way that your body is communicating with your muscles. So like I said, the smooth muscles have a striated or striped appearance. When you look at them under the microscope, it's kind of like, well, you can see with a muscle or with a piece of meat or something like that, that there are a lot of strands, fibers that run in one direction that make up the muscles. And those fibers shorten when the muscle is when a signal is sent to the muscle. Those fibers shorten, and the muscle shortens, it tenses up, and that pulls the two endpoints that it's attached to together towards each other, which causes movement of bones. So that's those fibers themselves are made up of bundles of smaller fibers, which in turn are made up of bundles of even smaller thread-like fibers. So it's like the muscle itself is like a bundle of fibers, and each of those fibers is a bundle of smaller fibers, and so on. So it's actually multi-leveled, multi-layered bundling of long straight pieces of protein that change shape a little bit in response to electrical potential. And so that electrical potential typically is a nerve impulse, but if somebody gets shocked, it will actually make their muscles jump too. Even, there's a famous experiment, I think it was Volta, one of the early people studying electricity found that they could cause frog legs to move even when they were no longer attached to a frog by applying an electric current to them. So, muscle responds to that sort of thing because of the structure of the protein that it's made of, and because of the way they're structured, that slight molecular change in shape is being repeated over and over and multiplied over and over by there being multiple fibers and multiple bundles of fibers and bundles of fibers that are all contracting. I hope that makes sense. It's kind of something that might have been better to have an illustration of now that I'm thinking about this, but it's essentially just a matter of lots of molecules changing shape, and that creating a change in the shape of the whole muscle. They're not changing form, they're not undergoing a chemical change necessarily, they're just changing shape a little bit because of the electrical charge at a molecular level, and that being repeated over and over again. So muscle makes up a really significant portion of a person's body weight. And exactly what portion is going to depend on a lot of things, but in a healthy, fit person, it might be half of their body weight, and it might be, more or less than that, depending on how muscular somebody is and how much other weight they have in terms of fat and things like that. But a very significant portion of a person's body weight is their skeletal muscles. So it's as tissue goes, it's a very nutritionally expensive tissue to have. It costs a lot of energy to maintain those tissues, and it costs a lot of protein to build those tissues and to repair them. So if those tissues are not being used to move around, which is mostly sensed through the bones, if the muscles are not being used, they atrophy, which means that they kind of ungrow. The body uses those proteins for other things, uses them for energy and that sort of thing. So if someone is a bodybuilder or something like that, and they're taking in a couple 100 grams of protein every day, and they're doing a lot of weight bearing exercise and stuff like that, they can build up a lot of muscle. But then if they stop doing that, a lot of that muscle is going to go away. It's going to rapidly decline towards a sort of baseline for that person. And what that baseline is for how muscular somebody is without working out a whole lot is very different from one person to the next, and is controlled probably mostly by genetics, but through the medium of hormones in the endocrine system. But yeah, that's something that if someone has an injury, if they have a sickness, something like that, that keeps them from being able to move around a lot, first and pretty quickly, they'll lose muscle tone, which is sort of a baseline level of tension in the muscles. That will go away pretty quickly, maybe even over the course of a week or so. If someone is bedridden for weeks, they're going to start having loss of muscle tissue, typically. And that's going to be something that they're going to notice as they're getting better, if they've been in bed for a while, or even if they have an arm or a leg that's been in a cast for a while and they haven't been able to move it specifically. That will lead to muscle atrophy, and that will lead to a lot of weakness and even change in size and shape of the muscles. So, if somebody has a bad illness and they're hospitalized for a month and they're not able to get up and move around very much at all, something like that, which is not such an unusual thing to happen in someone's life. If that happens, people will typically experience a pretty significant, pretty noticeable amount of muscle atrophy that will take a lot of working and a lot of time to get back to what it was before. So that's something that can change, and that a lot of people aren't really expecting to change, or don't know that that's a thing that is likely to happen to them. So sometimes people are really surprised and dismayed by it, but it's usually not, it needn't be permanent, and it's usually not an insurmountable obstacle. It's just something that takes time and work to get back to what it was. In just a minute, I'll be right back. So weight-bearing exercise is one of the best ways to get muscle to develop and to keep it from atrophying. And it also does the same for bones. If someone is doing weight-bearing exercise, it will help to keep their bones strong. This can be something as simple as hand weights or ankle weights. It doesn't have to be, somebody doing a full lifting regimen at a gym the way that they would if they were trying to be a bodybuilder. And walking is a really good form of weight-bearing exercise as well, because when you're walking, your arms aren't really bearing a lot of weight, but your legs and your back and your core muscles of your abdomen are all working together to hold you upright. And so they're all bearing weight and stabilizing. In addition to weight bearing, a couple other things that are really important for muscle health are aerobic exercise, which is any kind of exercise that makes you breathe harder, breathe faster because you're doing movement, and stretching. So aerobic exercise helps to promote stamina, conditioning the muscles so that they can, so that they don't get as tired as easily. Because that's a major thing, especially after somebody is recovering from a sickness or something and they're feeling weak. A lot of the time, it's not so much that they can't lift what they used to be able to lift. Sometimes it's just that they can't keep doing something for very long. I've talked to people a lot of times who say that after they were ill and after they were bedridden for a while, that something like doing dishes will make their arms sore after a few minutes and they have to stop. Or even just standing up will make them feel sore after a while and they have to stop much sooner than they would have expected. So conditioning the muscles through aerobic exercise is important for that. And then stretching is important to keep the muscles from going into spasm, and it often helps people to not hurt themselves by overexerting or overextending a muscle. So I want to talk a little bit about the different kinds of injuries and mishaps that can happen with muscles and with bones, and some of the things that we would do about them. So I've talked a little bit about atrophy with both bones and muscles, and how weight-bearing exercise and movement is helpful for that. With bones, the main things that people ever notice going on with them are if they fracture a bone, or if they have their bone density checked and find that it's lower than it should be. So, which is mainly a problem because it's a risk factor for a fracture. So, people wouldn't even notice that if they weren't checking for it, apart from the fracture thing. So, when bones break, that's a major injury. How major is kind of variable. So some fractures don't involve any displacement and are closed fractures, and those are the least complicated type. So this would be where there's a crack in the bone, but both parts of the bone are together. It's not broken in two, it's just cracked, and the sides of that crack are touching one another. The bone might not be able to bear weight without pain, but if you avoid further injuring it, it's going to heal with minimal complication. When there is displacement, and especially if there's an open fracture where a part of the bone has, if somebody's bone breaks and that part tears through the surface or tears through the tissue around it, so that somebody has, a broken bone end sticking out of their body, that's pretty much a surgical situation. That's going to take some surgery, often some hardware to repair that. There are methods that exist for setting and promoting healing in more complicated fractures, but I don't really use them, and I'm not going to teach them right now. because they're kind of not something you should do if you have access to something else. So people have gotten pretty good at fixing bone injuries that used to be nearly unfixable. But with all of that, the general idea is to get the sides of the bone to line up that should be together, and then take most of the pressure, weight, and so forth off of it so that it's not further injuring itself. And if those things are happening in an otherwise healthy person, in a matter of weeks, the bone will be remodeling and it will be growing together and getting strong again. In some people, especially older people, and more in older women than in older men, but there's a great deal of individual variation with that. Sometimes the bones do not heal together, even though the parts are where they should be. And that can be a problem. That can be a real challenge to someone being healthy and maintaining their independence and things like that. So there are different herbs that have been used for that. One thing that I like to do in that type of a situation is a treatment called moxibustion, which I've talked about before, and which we'll do a workshop on in the weekend intensive at the end of the program. But this is using heat from burning mugwort to kind of stimulate the process of inflammation, or to sort of imitate the process of inflammation so that the body tries to heal the area. So that can be helpful. Isoflavone containing herbs like red clover, which we'll get into here in a few minutes, that is also potentially helpful, because sometimes the reason that the bone isn't healing is because the body no longer has the estrogen available to signal to the body that it needs to deposit calcium into the area. And then, of course, adequate circulation to the area and adequate nutrition, especially protein, but also minerals, are really helpful to get that all to happen too. There are a couple of herbs like rock tripe and Solomon seal that have a history of use for promoting bone healing. And this isn't because they contain calcium, although calcium containing herbs are a great thing to have in your diet too if you're concerned about bone health. But it's actually because they have an effect on, it's probably because they have an effect on the endocrine system in such a way that they're causing the body to deposit more calcium into the bones and potentially strengthening them. So with muscles, on the other hand, there are a whole lot of different things that people notice going wrong with muscles. One of them is cramping and spasming. So there are muscle relaxing herbs for that. Skullcap would be an example, probably the example that I use the most often. Lobelia is another example. These are calming herbs that help calm the nerves to the muscles and help to relax the tension in the muscles. There are herbs for muscle stamina and soreness. Eleuthero and rhodiola are two that are pretty well known for that. When people take these, their muscles don't get sore as easily and maybe recover more quickly after a hard workout. So for a lot of people, if they work out really hard, the next day they'll be really sore. These herbs tend to help that not to happen as much, and also help to strengthen and heal the muscles from the minor wear and tear that happens during a hard workout. So those kind of herbs have been popular among athletes for decades because of that sort of thing. Contusions and injuries to muscles, crush injuries or bruising of muscles, things like that can happen because they're pretty soft tissue. Can I repeat those two? Hang on just a second. Yeah, I'm gonna write down the names of those two herbs, but I will say them again. They are rhodiola and eleuthero. All right. So I was saying that injuries to muscles can occur, from falling, from a lot of the time that happen during sports as well. People tackling each other or whatever. Also, just from working, somebody has a rough job or physically intensive job. Sometimes they'll get bruises and bumps and things like that. Occasionally, if somebody has a heavy object fall on them, that can cause damage to muscle tissue as well. Anti-inflammatory herbs are really good in that situation. And then warming things topically, things like cayenne salve topically can help to get circulation going through the area, and you know have a warming effect on the muscle and help it to heal. And then anti-inflammatories, things like ginger or willow, might have a reducing effect on the soreness, and in so doing might also reduce swelling and help circulation to be better. Now, if there is a significant injury where muscle tissue actually gets crushed, and this is something you might see in where if something heavy falls on somebody, or if part of their body gets caught in a piece of machinery and gets damaged. Sometimes you see something like that, there will be actually a significant amount of muscle tissue that gets destroyed and has to be processed by the body in terms of being destroyed proteins, which means that there's a lot of inflammation, a lot of immune activity going on at the injury site, and then there's a lot of excess of a substance called creatinine, which is sort of a metabolic waste product. You could call it a toxin, although it's not a toxin in every scenario, but in this scenario it is. A buildup of this substance in the bloodstream, because there might be more of it than the kidneys can handle. At any given time, muscle tissue is breaking down, muscle tissue is being built, and breakdown products of muscle tissue being destroyed or being processed by the kidneys. But if a whole lot happens at once, sometimes it's more than the kidneys can handle, and it can cause insufficiency of the kidney function, where fluid's building up in a person's body and the kidneys are not is able to process it, and things like that. So herbs that help the kidneys are useful in that scenario. Things like like abundant fluids for one thing, but also things like diuretic herbs like sumac, which I have here, or corn silk, or reindeer moss is one that I use. It's not a very widely used one, but it's traditional to Eastern Kentucky. And here's what it looks like. It grows on rocks and on bare ground, and it helps to stimulate the kidneys. So stimulating the kidneys so that they're not so that being overloaded by creatinine doesn't keep them from performing their other functions can be really important in that situation. So question here, do I use sumac as a tincture or a tea? For the most part, I make a water-based extract of it, and I put just enough alcohol in it to keep it from going bad, which is about 5%. It's got a lot of antioxidants in it. It has it has some sort of preservative properties of its own, so it doesn't need a whole high concentration of alcohol in it. But basically, I'm just doing a strong tea of it that I'm making shelf stable. You could do a tea from it. You could make a tea from it that was just, prepared when you want to use it. And that's a good way to use it because it is it contains a lot of water. So, having more water per amount of medicine, the way you would with a more drinkable sort of tea, is a good idea. With the extract of it, I have people take it with water, because it needs the water is really what does the water is really what does the cleansing. The sumac is just there to make the water move, to make the kidneys move the water. So those are some of the different scenarios where people need healing for their muscles and for their bones, and some of the different categories of herbs that you might use in those types of scenarios. Like I said, I really encourage everybody, especially with the bones. I mean, with the musculature, it's a little more complicated, but with the bones in particular, there really aren't that many of them. I mean, there's 206 bones or so in the human body, but most of them are pairs. Most of them are repeats. So you have a femur on each leg. You have a humerus and an ulna and a radius in each arm, and then the bones of the hands, of the fingers and toes, are numbered. So you don't really have to necessarily learn 200 different names for bones, but even though there are that many of them. So it's not as daunting a task as it might first seem like, to get to know the different bones of the body. The bones of the skull and the small bones of the hand are maybe the hardest part of that, but with a little bit of study, it's something that you can do. Hang on a second. All right, so yeah, there's a resource out there called the anatomy coloring book, human anatomy coloring book. And I think that is kind of a reasonable thing for a serious student of human health to have. It's not super expensive or anything, and it just has different pictures of different structures in the human body. And it's a coloring book, and it just helps people to spend a little bit of time focusing on each of those. The process of coloring them in helps people to spend a little bit of time focusing on each of them, and really helps people, in my experience, to remember where they are and what they look like. So, being conversant with all of those things is a pretty good idea, and not a huge investment of time on your part, especially with the bones. Like I said, with the musculature, it's a little more complicated, but knowing where the big muscles are is helpful. So, if somebody's talking about them, you can have an idea about what they're talking about. I'm more concerned about physiology of the muscles in general than about the shape and placement of individual muscles, but both are useful to know. And like I said, it's not something that you would have to commit an enormous amount of time to teaching yourself. So yeah, Wikipedia is a good resource as far as that goes. It's not like there's a lot of controversial information about where the different bones in the human body are or anything like that. And Human Anatomy Coloring Book is, I think, a fun exercise that is really, for a lot of people, helpful in terms of being able to remember all these things. All right, so I wanted to talk to you a little bit about a couple of different herbs. And the first one I want to talk to you about is called cup plant. Cup plant is not a really widely used medicinal herb, but it is something that grows here in Kentucky, and that is it's traditional here, but it's not like really a commercial herb. I'm going to show you a picture of it. I'm actually going to show you a couple of pictures of it. All right, so this is cup plant or Cyprium, and as you can see, it's in the sunflower family and has lots of small yellow flowers. Now, if you see just below this central flower with the bee on it, you can see that there are a couple other buds that are going to open. So each of the places where there are flowers, there will be a few flowers, not all open at the same time. And if you look down the stem from that, you can see that the leaves, it has a very squarish stem, and the leaves are arranged on opposite sides of the stem, and they join each other around the stem, clasping the stem, and form a little cup. And I've got a different picture that I want to show you that has a clearer view of that. So this is where they attach. And these ones are fairly young leaves, and as they grow, the cup gets a little deeper. But you can see right where they attach, there's a place where there's a sort of cup. And this holds water, and it may attract insects or something like that. That little vine there is a bindweed. It's kind of like a wild morning glory type of thing. But the place where they attach to the stem is the cup, and that is what gives it its name. So the flowers and buds of this plant, I'm going to go back to that picture. The flowers and the buds of this plant can be made into an infusion or a tincture. If you make them into an infusion, you have to pour the water over them and let it steep for quite a while. It sometimes helps to chop them up first because it's kind of harder tissue. But they've got some gummy, resiny stuff in them, and they will help to break up phlegm and congestion. And they've also got some starches in them that help to promote digestion. And so if you take it, if you have a cold, cough, something like that, it can help to break all of that up. It makes people sweat a little bit more, not as strongly as bone set does. But it has some oligosaccharides in it that promote good gut bacteria as well. So it can be a good thing to take after an illness when the body is working on replenishing its store of good bacteria. The nice thing about cup plant is, well, the leaves also can be used medicinally. The leaves don't have as much of the decongestant properties as the flowers do, but they have the digestion promoting properties. They can also be crushed up and applied topically to wounds, rather in the same way that yarrow can. I like yarrow a lot better, but yarrow is not always around. So instead, if you know about it, it's an herb you can use. Just take the leaves and crush them up and bruise them. And you can put them on bruises. You can put them on sore muscles, things like that. I haven't tried making a salve out of it myself, but it is something that people have made salves out of for sore muscles and aches and pains from exertion. So, I think that it's really important to know a variety of different herbs that you could possibly use for any given condition. So even though there are other herbs that I use more frequently for everything that I'm talking about for this plant, it's still a good herb to know about because it's good to have options It's good to have the possibility that, if yarrow didn't agree with somebody, or if thyme didn't agree with somebody, that you would have a different herb that you could use for that person. So even though it's not my first line herb for really much of anything, it is one that I still really like having around and knowing about, and want to make sure that all of you know about as well. When you do find this plant, you'll find very large amounts of it, because a single plant is sometimes 8 feet tall or so when it's fully mature. And if you find, if you pick 2 or 3 of them, you've probably got your year's supply of cut plant, especially since it's not usually a first line herb for me. But even if it was, if you pick 2 or 3 of them, you've got a few pounds, maybe 5 pounds of the herb, which is quite a bit. And it will often grow in large stands. This particular batch was growing near the river, which is often where I see it, is growing along the Palisades of the Kentucky River. Not exactly sure what it is that it likes about that environment, but it's an area with sandy soil and lots of calcium in the soil, and that floods occasionally and otherwise has good drainage. So for whatever reason, that's often where I see it growing in profusion, but it's also a plant that you can find growing in open fields, meadows, things like that. And bees like it. You can see them on there. So it's a good plant for pollinators, good plant for attracting butterflies and insects and things like that. And it's nice to look at. It's a nice looking and easy to grow plant, like many members of the sunflower family are. So the next plant that I want to talk to you about is red clover. And red clover is probably familiar to most of you. I'm going to get a little picture of it up in just a second. There is red clover, and as you can see, it has a bee on it, as did the other one, the cut plant. So cut plant is a member of the sunflower family, a member of Asteraceae, and this is a member of the bean family, Fabaceae, sometimes called Leguminosae. And red clover is not a native plant to North America. Cut plant is. Red clover is native to Europe and to Asia, and it was brought over here as medicine and as food for bees and as forage for cattle. So it's typically grows to about a foot or so tall and has these little ball-like clusters of flowers. Let's see, let me see if I've got a different picture that more clearly shows the flower. Okay, so you can see individual flowers on the ball-shaped thing is an inflorescence, and each of the little pink things sticking up is a flower. And you can see that at the base of each of those flowers is a little green thing that they're growing from. And each of those flowers has a tube-like part that contains nectar. So it's a really strongly nectar-bearing plant. It's also nitrogen fixing, meaning that it allows for conversion. It helps with the conversion of nitrogen from the atmosphere into a form of nitrogen in the soil that other plants can use. to make aminos, to make proteins and things like that. So it's something that is sometimes grown as a cover crop and then plowed under so that the soil will be more nutritious for subsequent plants. And like I said, this is a plant that was partly brought here as medicine. So it's a very strongly traditional plant in the folk medicine of Europe. And I think probably one of the more well-researched plants from that tradition in terms of how it works in the body. At least certain aspects of it are. So where I'm from in Eastern Kentucky, this plant was often used as a purifying tonic, a blood purifier, something that people would take with the hope of stimulating the liver and getting the liver to remove substances from the body. So that's one of its traditional uses. But most of the modern research into it has focused on its content of certain substances called isoflavones. And these are sometimes also called phytoestrogens. And the isoflavones they're isoflavones because of a particular structure that they have. They're called phytoestrogens because they work like estrogen in the human body. They don't have a structure that's similar to estrogen. They're not actually a similar compound chemically, but they have a similar enough shape that they attach themselves to the places on cells that estrogen would attach itself to, and in so doing, activate the actions in those cells that the estrogens would activate. And so we could describe it when it does that as promoting estrogen activity. Increasing estrogen activity. However, it is weaker than the body's own estrogens. So in a person with high estrogen, it can actually get in the way of their estrogen and decrease total estrogen activity. And in a person with low estrogen activity, it can add to the total estrogen activity by binding to receptor sites that don't have anything binding to them. So it can actually balance the estrogen activity in the body by either increasing or decreasing the amount of estrogen stuff that's going on, estrogen responses that the cells are having. So one place that this sees a lot of use in terms of clinical stuff is in people taking it to replace estrogen when their estrogen levels have declined because of aging. And so a lot of the time people experience that as things like hot flashes and night sweats and what people might describe as menopausal symptoms, although they don't only happen at menopause. So sometimes people take it for that, and sometimes people take it for health because in an older person who would have very little estrogenic activity, it will tend to increase that. And because estrogen is one of the things that tells the body to deposit minerals into the bones, it can result in stronger, healthier bones. Of course, in order to do that, there has to be enough calcium. There has to be an abundance of calcium in the bloodstream, which can be a hard thing to do, can be a hard thing to ensure. Calcium is one of the most popular supplements out there. And also there's a whole industry, the whole dairy industry has done a lot of marketing about dairy as being, something that's good for strong bones and stuff like that. Although there's actually a pretty limited amount of evidence to suggest that that's really the case. And of course, more people than not are lactose intolerant. So, it's really our main source of calcium is from plants. from vegetables, green leafy vegetables, which often contain a more usable form of calcium and more of the calcium than dairy products do. I think there was an essay by, well, I can't remember what it was what the actual work was, but I believe it was by Ralph Waldo Emerson, in which he was talking about how he knew a farmer who always drank milk because he believed that a vegetarian diet had nothing in it to make bones. And then, you know, Emerson is kind of laughing at him because he's plowing the fields with an ox whose vegetable made bones are much stronger than the person's are. Not that we can necessarily eat what an ox eats, of course, but our main source of calcium is from plants. And calcium from dairy is in some cases not going to be that absorbable because the acidity from the amino acids in the dairy might cause people to actually lose more calcium than they retain. There was actually a study done about that here in Lexington by Professor Roger Anderson at the University of Kentucky Medical School many years ago. And there have been other studies disagreeing with it at other places, but you know, it's probably different in different people, and that different nutrients probably work very differently in different people's bodies. But red clover can help with promoting healthy bones. It can help with balancing the endocrine system, especially in terms of how the estrogen is working. And because it can do that, it can also have some effects on fertility, on making fertility cycles more regular. And it has other roles in tissue healing as well. It's been used in some types of cancer to try and prevent vascularization of cancers. So basically keep the body from providing circulatory tissue into tumors, because cancers rely on the circulatory system to bring them nutrients. And if no blood vessels grow into the cancer, then the cancer cannot really live so well. So red clover has been used in herbal formulas for its ability to prevent that from happening. Like I mentioned a minute ago, there has been quite a bit of research into the isoflavones in red clover. There's also been a lot of research into the isoflavones in soy, and it appears that red clover has a little wider profile of these substances than soy has. So soy has fewer kinds of phytoestrogens, fewer kinds of isoflavones than red clover has, at least that people have identified and documented. In terms of the parts of red clover that are used, all parts of the plant contain isoflavones, but the flowers contain quite a bit more. And so they're traditionally the part that's used medicinally. So if you get red clover from somewhere that sells herbs, usually what you'll be getting is the flower heads. Good quality red clover is pink, it's not brown. So if red clover dries too slowly, it turns brown and it produces these substances called dicumarols, which affect platelet activating factor. They're blood thinners. So red clover that's dried more slowly has a blood thinning effect, and this can be significant in animals that are being fed this as a big part of their diet. And it can also be significant in people taking red clover as a medicine who are also taking blood thinners. So you don't want to really take both at once unless you're pretty sure that the clover is higher quality. You know, if it's something you've dried yourself and you've managed to dry it while it's still pink without it turning brown, then you probably don't have to worry about that. But with commercial red clover, some of it's, it's not very good quality, or it's dried too slowly and it doesn't have a nice color to it. And I really wouldn't use that if I were to buy it from somewhere, but some people do, and it does have some different medicinal properties as a result of that. It does have that blood thinning effect. But generally speaking, good quality red clover flowers will have more of the isoflavones in them that make them do the estrogenic type activities than the leaves would have. The sprouts made from the seeds actually contain even more. So if you're able to get red clover seeds, which sometimes you can buy as a commercial thing because people sell them for sprouting, but sometimes you can also get them from harvesting red clover when it's towards the end of the flowering, when the flowers have started to turn brown on the plant, and just hanging it upside down in a bag. And a lot of the time it will finish going to seed after you've picked it and drop those seeds into the bag. So that's kind of a painstaking process, but if you want to gather your own, that's how you do it. There are also red clover seeds that are sold as a landscaping thing, but those are basically always, as far as I know, coated with sprouting inhibitors and other things, and they're not fit for human consumption. So don't ever try to use those. But there are red clover seeds that are sold for human consumption that have been handled accordingly. And so that's what you would want, red clover seeds that were intended for growing sprouts. And the way you sprout them is you put them in a jar, you pour cool water over them, and then pour it off. And then you do that once a day for 3 days or so, and they'll start to sprout. And at that point, when they've started to sprout, but they haven't started to turn green yet, at that point, they have a lot of the medicinal compounds in them. The leaves of red clover also contain some probiotic substances. So if you were taking the leaves medicinally, it would be a reasonably good way to reestablish gut flora after a diarrheal illness, for instance, or after a round of antibiotics. So that's another way in which red clover can be used. And red clover tea is something that sometimes people drink just for the flavor of it. It's sweet, has a kind of almost honey-like flavor to it. And so that is medicinal, and it is also something that people can just kind of drink in an almost food-like sort of way. I have seen it induce lactation in a person one time who was taking about 1 liter of it a day. So, that's probably an excessive amount. But it doesn't do that if you're just taking a cup or so a day. All right, so that's red clover again. And, it and the honeybee are both from somewhere else, but fairly naturalized here. You will often see red clover growing along waysides and in old fields. You seldom see it growing far out of the reach of human habitation. It doesn't tend to grow like way out in the country, or way out in the woods or anything like that. It grows out in the country in pastures and fallow fields and things like that, but only in areas that have been stirred up quite a bit by humans. It doesn't grow way out in the woods or in clearings in the woods or anything like that typically. So its ability to get itself around is fairly limited. The seeds fall on the ground right where the plant was and grow there. And the plant also, it kind of reproduces through runners, stems that grow along ground under the grass and send up new little clumps of red clover. So it spreads and it drops seeds, but it's not real invasive. It's not real aggressive or anything like that. If you want to grow it in an herb garden, it's pretty easy to grow. And most of what I have said about red clover just now applies in some degree or another to most of the family that it comes from, the Fabaceae, which is beans, generally speaking. So if you made sprouts of other kinds of beans, they would likely have a lot of the same isoflavones that red clover does. But red clover contains a wide variety of them, and it's something that is, because of the texture of it, it's particularly digestible, particularly good available source of them. And also it puts out flowers for a long period of time. So like if you were to grow something like, say, snap peas or something like that, and pick the flowers off of those, you would only get them for a couple weeks a year, maybe less than that. Red clover is going to have flowers on it from late spring up until mid-fall or so. So there's a big section of the year during which you can harvest red clover. And that's part of the reason why it's the usual thing to use for that type of process, for that type of medicinal property. I tend to gather most of my red clover in June. It's a time when you can go and find a whole lot of it. By July, there's usually there's some here and some there, but not nearly so much. But in June, you can go out and you can gather, a bushel of it in a day. And then, at least as far as for my practice, I'm good for the year if I've got that. So it's something that you can gather an adequate amount of at various different times of the warm part of the year. But if you gather it at the right time during the June honey flow, you can get a whole lot of it. And when that time is going to vary depending on where you live. That's when it is here. And it would be 2 weeks earlier if we were a couple hundred miles further south, and it would be a few weeks later if we were further north. Just kind of depending on the local climate. Hang on, I will be right back. All right. So yeah, red clover is good for detoxification, cleansing, stimulating the liver, and it is got some applications for digestion and for helping to balance the endocrine system. Whereas cup plant is good for congestion, also helps some with digestion and reestablishing gut flora, and can be used topically for wounds, including contusions, bruises, blunt force injuries. So those are some good herbs to know about. Red clover is consistently one of the most widely used herbs in North America, and cup plant is kind of obscure as far as medicinal properties go. But I feel like it's useful to teach both of them to you. Hang on just a second. So on either Saturday or Sunday, October 21st or October 22nd, I would like to have the next herb walk. I would appreciate any feedback from any of you if one of those dates works better than the other. I could do either one, but that's going to be a good time to be out and to be able to look at what's growing and what's going on in the natural world at that point. And that will be, well into fall. If we wait much longer than that, there's not going to be as much to see. But if we go at that time, we'll be able to kind of look at what things look like in late autumn and kind of, see what that plant community looks like at that time. I want to do this one at Heisel Farm Park again. So we'll be going back to that place that we looked at during the first herb walk and seeing how things are different at this time of the year and what's similar and what's different, but quite a few different plants that will be prominent at that time of year. So that will be, I know that not everybody is going to be able to be physically present for it, but I do plan on live streaming and recording it. With the last time I tried that, it didn't work out so well, but I'm going to try that again. And hopefully people will be able to watch it as it's going on if they're not going to be able to be physically there. But if not, it should be recorded as well. And I think that will be, a good learning opportunity. It was a nice herb walk last year when we did it at that time. So, like I said, if you have a preference between those two times, let me know, and it will be one of those 2 days, one of the days that weekend. Okay, any questions as far as either the two herbs that I've talked about today or about the musculoskeletal system? All right then. Well, thanks for coming, and I will talk to you again soon.